Ohm's law is a fundamental rule in any circuit analysis. It relates current and voltage and is one of the most useful, simple rules that you will find. Whenever you get stuck in solving a complex problem, try applying Ohm's law. As these electrons come from every atom in all the materials that we know of. There are three categories of materials. Conductors have the ability to conduct electricity. They have a large number of electrons that are free to move about. They can thus move and create current flow when a voltage is applied. They easily facilitate current flow. Insulators have a lot of electrons, but most of them are not free to move around. They are trapped in the structure of the material, and they do not permit current flow very easily. Semiconductors are materials who can be selectively adjusted, and they are between insulators and conductors. Current flow is one of two types. Electron current is the direction that electrons actually move through a circuit. Conventional current, for historical reasons, this current is defined to flow from the positive to the negative potential in a circuit. Current, by definition, is the time rate of flow of electrical charge, and the ampere, unit of measure, is defined as 1 coulomb of current is flowing through a given cross-section in 1 second of time. A coulomb is actually a very large number of electrons. Voltage is very much like a pump in a water distribution system. The battery allows pressure to be applied to the electrons to get them to move. This is called an electromotive force. 1 volt, by definition, is the potential difference or voltage difference between 2 points when 1 joule of energy is used to move 1 coulomb of charge from one point to the other. 1 volt is 1 joule divided by 1 coulomb. Resistance. 1 ohm of resistance exists if there is 1 ampere of current in a material when 1 volt is applied across the material. It is a minor opposition to current. The unit of measure is an ohm, and this is a property of a material that, while it allows current to flow, restricts the amount of that current. Ohm's law is a mathematical relationship between the voltage and current and resistance. It's one of the most fundamental and important laws in electricity and electronics. And it states basically that as the voltage across a resistor is increased, the current through the resistor will increase. Graphically, it is a straight line with a slope of 1 over the resistance. Ohm's law can be written in 3 forms. Although it is fundamentally V equals IR, by applying simple algebra, we also find that the current is the voltage divided by the resistance, or the resistance is the voltage divided by the current. As a graphic reminder, we have the circle in which we can see that the current is the voltage divided by the resistance. The voltage is the current times the resistance, or the resistance is the voltage divided by the current. As a couple of examples, if we have 3 milliamps flowing through a 27 kiloohm resistor, 3 milliamps times 27 kilo actually equals 81 volts. 5 microamps multiplied by 100 mega ohms results in 500 volts, or 2.5 amps flowing through a 47 ohm resistor produces 117.5 volts. Similarly, we could find the resistance in a circuit if we took 8 volts and divided by 2 amps to find that the resistor is in fact 4 ohms, that 12 volts divided by 4 milliamps is 3 kiloohms. Or, as a third example, 30 volts divided by 15 microamps is 2 megaohms. Ohm's law is one of the simplest, most powerful principles in electronics, and it tells us simply that a volt is equal to the current times the resistance, which is a linear relationship.